Hi, everyone, and welcome to our Ask a Geologist program. So today I'm happy to announce that we have Ethan Penner here with us. And Ethan he got his master's degree at Binghamton University, and he's a geocommunicator on social media. And today he's going to tell us how to identify rocks and minerals we find. So without further ado, Ethan, you can go ahead and take it away.
Gotcha. Thank you so much, Ria. I appreciate it. So, I'm going to be talking about mineral identification today. I'm glad everyone was able to hop on and hear this talk. So, a little bit about me, just to start. Obviously, my name's Ethan. As Ria said, I got my master's from Binghamton University in 2022. But before that, I actually was also in the 4-year program for Binghamton for my Bachelor of Science until 2021. And then I started my master's that same year that I was graduating through a special program. It was a 4+1 program, accelerated, a little bit stressful, but I was still able to get it done in time. During that time, I also interned with the USGS for the Youth and Education and Sciences program. This was through social media because of the progress I had made on social media as a geocommunicator. Through this social media, I've gathered gained a following of more than 1.9 million followers on TikTok, Instagram, starting on YouTube as well. And then a little bit about me for my minerals and my fossils that I like. I'm a big fan of amethyst, although some people say it's boring. Azurite, malachite also as well. And then for fossils, I also like brachiopods because in Binghamton, they were a very popular and widespread thing to find. So it's just a little bit about me. Moving on to my background. You might think that I only specialized in minerals based on the title of the presentation, but I actually specialized in tectonic geomorphology. I used my undergraduate courses in structural, geophysics, historical, all of the basic core classes that every geologist needs to take. Used that to refine my focus and figured out I wanted to basically study how earthquakes can change a landscape. And I aimed my study to central New York and the Saratoga-Ballston Lake fault system, my bad. Use different methods of analysis like mountain front analysis and ground penetrating radar, just some geomorphology and geophysics there that I was able to apply to my thesis. And then I also, in my pastime, not for education or not for my academic career, I record myself breaking rocks open on social media. And so that's where the mineralogy comes into it. I'm able to entertain and educate about geology through these short form videos where I basically identify minerals. So if I focused on tectonic geomorphology, why am I going into social media for mineralogy and also paleontology in a way for fossil ID? So for the last 2 years and going on my 3rd year this year, I've been identifying rocks, minerals, and fossils using the knowledge that I gained through my classes. And also using field guides, external resources to help refine my understanding of these minerals and fossils and rocks. I don't consider myself an expert. I'm a geologist, and I don't think that I'm not an expert in tectonic geomorphology, but for mineralogy, it's a little bit tougher to claim I have a basis for identifying them. But my goal is that I want to make it easier for everyone else to understand identification, especially if they haven't gotten the opportunity to take the classes that I took and know and have the background so that they can also gain some understanding and have fun with rock ID. My expertise is mainly refined to the Northeast United States, mainly in New York, Connecticut, Pennsylvania, metamorphic belts, some sedimentary areas as well. But I also just went to Iceland this past summer, so I got to experience a little bit of volcanology, a little bit of volcanic minerals and that formation, plus a lot of glaciers, a lot of understanding how they can shape the landscape as well. But I got to experience and find olivine. I found zeolites, which you can't always find in the United States. So hopping right into it, how to identify a mineral. That's the question you're all here for. That's what you want to know. So I have here, without using the rock identifier app, that's just a little bit of a prejudice I have, because people always say, well, I use this app and it identified it as this. But I'm going to tell you the 4 main things that I use, so that you're not relying on an app to tell you what rock or mineral or fossil that you found, so that you can have that knowledge in the back of your head. So number one thing is that you want to know where you are in your country, in your state, because that will basically tell you, it'll give you the basis for rock hounding and what you want to find. So if you're in New York, you know that you're not going to find malachite, or you know you're not going to find aquamarine. These are rare minerals. They're very specifically concentrated in other countries. But what you can't find is quartz, garnet, pyrite, a little bit of fluorite. You can find fossils in some areas. But knowing that, then you can say, you can refine your expectations. So if you go out and find clear crystal, you're going to say, okay, this is quartz. Or if you find a maroon crystal, you'll say this is more like a garnet. You're going to find a lot of glacial erratics too in New York, but you might not find those in the southern states. If you're in Florida, you're out of luck entirely, because you're just not going to find anything. There's nothing there in Florida. I'm kidding. There's some stuff in Florida, but you're not going to find a whole bunch of rare minerals. So you might want to go a little bit northern, to the northern states like Georgia or Tennessee. Stick to your gut, but only sometimes, because if you think it's quartz, it's probably quartz. Things can be deceiving on the outside, though. If you find a boring looking rock, you might need to break it open. That's what I do. But that's why, because you don't necessarily know everything about a mineral or a rock based on the outside. Remember the tests. You have hardness, you have luster, you have streak, scratch. Actually, scratch and hardness are the same thing. I put that in there twice. Hardness, streak, luster. You have other things that you can't necessarily do in the field, like specific gravity. But these are very simple tests, and they will tell you a whole lot about a mineral that a rock or book won't necessarily tell you. And then lastly, don't hesitate to get a second opinion from someone who's an expert in mineralogy, who does this literally for a living. Not necessarily me, but people who are gemologists, or people who are crystal collectors, who know what they're doing. So just for reference, this is the Mohs hardness scale, if you haven't seen it before. At the very top, you have a diamond, which has a hardness of 10. At the very bottom, you have talc, hardness of 1. Talc is the softest, diamond is the hardest. You probably know that. But what you might not know is that to test this, you can use different materials. You can use your fingernail, you can use a penny, a knife, a steel nail. Very top, it's a masonry drill bit. It's a little bit harder, but that's how you can tell whether or not you have quartz or whether you have calcite. If they look similar, you can say, okay, I'm going to take my copper penny and take it to the calcite. If it scratches it, it's probably calcite. If it doesn't scratch the quartz, it's probably quartz. You can also find topaz. Topaz can be clear. But that's why you don't always want to rely on the hardness, but it's probably one of the most useful methods to rock ID, as opposed to just relying on luster or color or acid test. You get what I'm saying. So a little bit of an application. Like I just said, I mentioned calcite and quartz, very commonly mistaken minerals for each other. You can tell why. They're mostly clear, and quartz usually has and they both usually have a vitreous kind of glassy look to them, but quartz is often more glassy, and calcite is often more resinous. It can be waxy. It can not have that purely transparent look to it. Well-formed crystals might, but you really want to use the test for hardness, as I mentioned before. Quartz is not going to be scratched by a simple knife. Calcite will be. If you have an acid bottle, which I have here, make sure you label it with acid. That it's not, a common thing that you can mistake, and for your eye drops, who knows? But calcite or carbonate, which is what it is, carbonate will fizz when in the presence of acid, and quartz will not, because it is a silicate. It's not a carbonate. So for a demonstration, I'm assuming I'm visible right now. If not, I can stop sharing my screen. But let me get some of this stuff ready. As I mentioned, so let's do a soft versus strong test. I want to take a piece of gypsum that I have here. Gypsum is a 2 on the hardness scale, and then we'll take the same quartz. So if I take the knife that I mentioned before, I take the knife to the gypsum, and I just drag it along, and I see that it scratches. And I say, okay, so it's obviously not quartz. Gypsum and quartz are not the same color, but gypsum does scratch under a knife. I take it to quartz. I look for that line that I saw in the gypsum, and I'm not seeing it. I'm hearing the sound, but I'm not seeing it. And that's because quartz is so much harder than gypsum. And it's not as hard as diamond, but you will not scratch it with a simple knife. You'll need something harder. Sometimes a piece of quartz will suffice. Sometimes you'll use diamond-edged blade to scratch it. Color variation. So I just mentioned quartz. Quartz is one of my favorites because of how simple it is of a mineral. But what happens when you alter the chemical composition of quartz? You'll get rose quartz. You'll get amethyst. You will get citrine. This is a very tiny piece of citrine. And you'll get smoky quartz. These are all the same family of mineral because they're silicates. They're silica. But slight variations in their iron content and their aluminum content within the crystal structure will produce these different colors. And so people sometimes mistake them and say, well, you have a different mineral. And yes, it is a different variation of the quartz, but it's still the same type of thing. It's still the same crystal structure. Oftentimes, the quartz family can have different structures, like rose quartz might form differently, but they can form in the same ways. Fizz versus no fizz. So like I mentioned before, carbonates will fizz under the presence of acid. If you take a generic quartz, this piece of quartz right here, I take my bottle and I just line it with the acid. You're not going to be able to see this because this is a very small reaction. But there's no bubbling. I can put it up to my ear and there's no sound coming off it. There's no fizz. This is a piece of a weathered beach quartz that I found when I went to Cape May, I believe. But then I take this piece of carbonate mud, and this is not necessarily calcite. This is carbonate mud. It has the chemical in there, but I wanted to get a good reaction. Carbonate mud is probably one of the best ways that you can get this reaction to happen. Take the acid again. I line it all along. I can get this to work. All along the mud, and I put it up to my ear. And it's not a strong reaction. It's not a very chemically concentrated carbonate, mostly because there are actually brachiopods in this. I was just looking for a fossil or a sample that would produce a reaction. I don't think I can put it up to the camera so that you can tell, but there is a fizz going on there. And that's just to demonstrate that, like I mentioned before, you don't necessarily want to rely on the acid or any single test, but this is just to demonstrate what you can do with different minerals. One of my favorites, also, I actually forgot to mention earlier, with color. Another form of this is with mica. Mica is a sheet silicate. It can occur in two forms, or actually multiple forms. But the two most common forms are muscovite mica and then biotite mica. So biotite mica is black, brown, very dark. Muscovite mica is a little bit lighter, but they both have this kind of reflective, vitreous kind of appearance to them. They both have, this is the word for it, perfect cleavage, which makes it so that they break into exact flat sheets. And this is because they are sheet silicates. And mica actually resembles gypsum to some form, but as I mentioned, mica has that perfectly flat nature to it. Gypsum does not. Gypsum is a soft sulfate. Mica is a sheet silicate. Finally, one of my favorite things to do is when I find a metallic mineral. This is a metallic luster. It's not glassy, it's just reflective, very dense. Heaviness and density is actually another very useful tool. You have a magnet, you can take that magnet to whatever sample it is, and it'll stick. Because this is a metal, and if you have a piece of, say, coal that very much resembles that, and you want to say, well, is this a metal or not? It's not dense, but you want to test it. Not sticking. It's just dropping. There's no magnetism there. And actually, a funny thing that you can do is if you have a magnet, this is a little bit of a science experiment I just did like 2 seconds ago before the meeting. If you have a magnet and you have other metallic objects, you can almost magnetize very slightly the rock. You take the magnet away. Actually, no, you don't take the magnet away. You take the magnet and then you take the metal, such as the nail or penny that you can use, and you try to attach it to the rock, and it'll stick. But I'm not sticking it to the magnet, I'm sticking it to the rock. And this might just be because of the proximity to the magnet, but I believe that it's also slightly altering the magnetic field of, in this case, the magnetite, to actually have a charge to it and attract the other metals. So going back into the presentation, that was my little application. Hopefully you were able to see it. What if my knowledge isn't enough? What if I want to know more? And as I mentioned before, the internet is super helpful because you can get that extra knowledge. You can get that expertise in the form of books. As I mentioned before, you can have field guides for rocks and minerals, such as in the form of the National Audubon Society field guide. It has pictures of different metallic minerals. You can get different colored minerals, yellow, brown, blue. It just goes by color usually, but it also groups them individually by crystal habit. You can get field guides if you're just interested in geology itself. You can understand different landforms. You can understand groundwater and how it interacts with them. That's just a little bit of my geomorphologist inside of my brain talking. You can get region-specific guides. This is for the northeastern United States. You can get one for the Midwest, West, Southern states. And it'll just tell you how it was formed, the history of it, and maybe what minerals you can find. And finally, you can have these books that I'm sure everyone had these as a kid, Rocks and Minerals, 1,000 Facts. And they have various things about how hard minerals are, about schist, metamorphism, deep sea sediments. Everything that you can think of is probably in one of these books. And you can get them all over the place, not just online. You can also get them in museums, in libraries. You can also get rock hounding guides in the form of websites as well. You can just look up what rocks can I find in my state, and there will be a guide for that on the internet. And then the last thing that you can do is consult others, not necessarily experts, but if you just want a second opinion, you can consult people like me, people like others that you find on social media. You can just literally message me and say, what did I find here? Please help. And I will say, absolutely. I can't necessarily guarantee that it is this, but based on my experience, I think it's this. And then I'll always recommend an expert because that's what you want to do. You want to pass someone on to the best chance that they have to identify them. And I do this almost every day. I help people because they want to know what rock they found. That's just basically all I get from my DMs. So why am I telling you this? Why does it even matter that you should correctly identify minerals? Because you don't want to be wrong. You don't want to identify something as a diamond. Sure, you found a pretty crystal. Sure, this could be, you could say this is a diamond and pass it off to someone who doesn't know, but you'd be wrong. You don't want to be wrong. And that's the worst thing that especially that I think is happening. People are just wrong a lot of the time and they think they're right. They defend themselves, but there's no harm in just making sure that you're getting things correct. And so these people that pass things off as fake really damage the crystal industry, the geology, the academia of geology, because people spend so long teaching about geology and they spend so long educating themselves. And then just for people to go online with a large audience and say that, oh, I found this this red quartz, or I found this yellow, or I don't know, a crazy green color quartz, or I found this jasper in the bottom of a lake and it's just planted there. You see those videos a lot, and it's really infuriating as a geologist because you're going to get people who just are able to have that influence, and you can't do anything about it because people won't always trust you. And as I said, they're misleading locations. People said that they found crystals at the bottom of a lake, at the top of a mountain, when there's nothing there. They just made that up. And so this is all just to influence the community and make it a positive one instead of a toxic one, because you don't want to be known as an area of academia, as an area of science that's negative and that doesn't help people grow as rockhounds, as geologists. We only want people to succeed and do better with geology, because that's the whole goal of people going through school to be a geologist. They want to do academia. They want to spread their research. They want to work in the field and bring minerals to the public. So this part's going to be a little bit boring. Just me talking about what mineral ID can be used for in the future and what things are being done for it. Actually, I forgot to touch on the last slide, actually. For fake minerals, a lot of the times I see malachite. Malachite is probably one of the best examples of a fake mineral. Not necessarily malachite, but fake malachite. And if you've ever seen fake malachite, it's often in the form of parallel bands, what you'd expect for an agate. An agate's just a form of silica. It's very similar to, it's actually in the quartz family. But malachite does not have parallel banding, or I guess it does in a way, but it's not straight banding. So that's what you don't want to have. You don't want to have straight band. You want to have, this is a polished piece of malachite, but you want to have this kind of deep green, dark green, light green variation. You want to have the alteration of the banding. You want to have different directions. And like I said, you want to test it. That's what a number one thing that you can do is test hardness, luster, different things that you wouldn't normally see in a fake piece of malachite. That's just I forgot to mention that before. So as I mentioned before, mineral ID apps. These apps cost money. They require service, and they rely on some form of accuracy to be successful, obviously. But that doesn't always happen. They're expensive. You do need service to run them. So if you're in the field and you want to identify a mineral, you can't always do that. And they're not always accurate. They might see this piece of beach quartz that I have and say, oh, this is an agate. And then they'll offer different options. Maybe it is quartz, but they'll also say it could be agate, it could be jasper, it could be all this stuff. And it's not giving you a definitive answer. That's the problem with them, because people rely on them and they pay them money, but they're not always going to be 100% right. They need to see this crystal and say, oh, this is quartz. But you could just take this quartz, message me and say, is this quartz? I'd be like, yes, it's quartz. Did you do the hardness test? Did you do this? That's what the app can't do. It will say it might be this, but unless you do those tests yourself and you can really just hold the mineral in your hand and understand it yourself, then it's not really worth it just to look at an app and say, okay, that might be a jasper or it might be a quartz. You never know. Other things, XRF, X-ray fluorescence. That's just a way to analyze the elemental composition of a mineral. There's improvements with that. Mining industry and science and labs and geologists use it to understand the makeup of a mineral. Improvements with that can help to basically confirm or deny whether minerals are present in very small samples. Near-infrared spectroscopy. Spectroscopy is just basically using or measuring the spectra that are emitted from a specimen, and using near-infrared radiation is a new form of analysis that is being used to improve the elemental analysis and the properties of minerals to be more accurate. And if you were able to apply these to a mineral ID app in some form, it would greatly help. It would probably cost a lot more money, but it would help to basically ensure that you're being right. And then finally, automated mineralogy, just a new way to map rapidly in the field, identify samples at a better pace, And basically, just to summarize all this up, mineral ID is a very finicky thing. You're not right all the time. Usually you're going out into the field with a hand lens of some form, looking at rocks, looking at minerals. You find something, you think it's quartz, it's probably quartz. You find a fossil, and you consult people. It's a very simple thing. But the more people that do it, and the more people that do it right and more often, the better the community will be, because we want to find minerals. We want to find quartz. We want to find diamond. But a lot of the times people just make videos saying they found a crystal when it's just glass or plastic, and they polished it and cut it up into a fake crystal form and sell it, on Etsy or Amazon. And there's no way to stop that. So really just got to be careful where you're finding crystals, what you're doing, who you're buying from, what you're buying. And then, as always, just basically talk to geologists. Geologists should be the ones, geologists, gemologists, basically anyone who deals with these minerals as a line of work, as a hobby, will be trustworthy and will give you an honest opinion, because that's what we want to do. We want to spread positivity. We want to make things easier and for people who didn't take these classes. And yeah, that's all I got for you guys. Thank you so much. I really appreciate being able to give that presentation.
Thank you so much, Ethan. That was amazing. So we do have a lot of questions for you. So yeah, you can go ahead and take it away.
You got muted, Ethan.
I did mute myself. That's kind of embarrassing. All right. I was just going to take a second. Oh, boy. Okay. So starting off with the first question, is the streak test useful for mineral ID? And I believe yes. I forgot to mention this before. That's a great question because I forgot to include it in my presentation. I don't have a streak plate, but what I do have is this piece of quartz, and I have this coal. So if you have a mineral with a known color, say coal is supposed to have a black streak, and say you have a piece of not malachite. I talk for 20 minutes and I can't talk now. That also is black, but it's actually going to have or hematite actually. Say this is hematite. I don't have hematite on me right now, but hematite has a brown streak. So if you take this coal and you rub it on the streak, let me get that nice and marked up, you will see that it leaves that kind of black marking on it. And then say you have the hematite, you do that same thing. The magnetite. It's not going to leave a streak. Actually, oh, look at that. I believe this is actually, nope, that is brown, or that is black, never mind. But it would leave a brown mark. So the streak test is very useful, but not for every mineral, because quartz isn't going to leave a streak. It's going to be colorless. So not every mineral leaves a streak. Some minerals have the same streak. There's a limited amount of colors. And so every test is, sorry, very useful. You just want to use a variety of tests, because if you only did one thing, it's like a daily routine. If you only just woke up, brushed your teeth, and then did nothing for the rest of the day, that's not a very productive day. You want to add things on and just kind of make sure that you're touching all the bases. Okay. Second question, what are Herkimer diamonds? What about Cape May diamonds? Very good question. So these diamonds that you're referring to are very just differently formed, and actually have. Actually, I just realized something. I called this citrine earlier. It's not citrine. I did that in one of my videos too. It's not citrine. It is a Herkimer diamond. It is citrine, just forms in a similar way to this. This is a yellow tinted Herkimer diamond. Herkimer diamonds are quartz that forms in a very specific way and only forms in the Herkimer mines. This is how quartz is most often formed. And this is the Herkimer diamond, a very tiny one. And so I haven't seen a Cape May diamond, but I'm assuming that the Cape May diamond is a similar fashion to the Herkimer diamond, in that it forms that in that certain way only in Cape May, but it's just basically quartz that is unique to that spot. and so you can't find it anywhere else. So if people say they have a Herkimer diamond from California or Herkimer diamond from a different country like South Africa, there's no Herkimer diamonds, or I guess there's no, maybe like Iran. There's no Herkimer diamonds in Iran. There might be specific quartzes to those places, but not Herkimer diamonds. What made me decide to study geology? That's a good question. I have an uncle that was a geologist, and that was basically my introduction into geology. I wanted to follow in his footsteps. I wanted to do science of some sort, but I didn't know how. And I got stuck with a box of rocks when I was young. I liked looking at the minerals, but actually I wanted to do marine biology to start. Excuse me 1 second. It wasn't until high school when I realized that I actually was bad at biology that I said, okay, sticking with geology. I didn't actually decide that I wanted to do social media until my senior year of college. So it was very late on. It wasn't necessarily from the start that geology was set in stone for me. But as the years went by and as I was exposed to more science, I said, yes, this is what I want to do. How did I start posting rock videos on social media? That's also a very good question. Thank you for asking that. Basically, I got bored during the pandemic. I wanted to do something that went viral. TikTok was a great place to go viral. And what else would I want to do when I have nothing else to do? And I made the rock videos just because I wanted to relate it to geology. And as time went on, as I kept posting, I said, okay, I'm going to refine this. I'm going to include more minerals. I'm going to include fossils. And that's kind of how it shaped. And I decided, well, I have a big page now. I'm going to refine it into more of a geocommunicator aspect and post educational content, maybe talk about different minerals you can find in different states, or maybe other things like funny things like how stalactites form in caves, that kind of stuff. The next question, what is the coolest mineral or rock you have broken open for a video? I get asked this a lot. The coolest rock I've broken open, I think I have near. I do have near. I have my most popular video I have of me breaking open a rock, and it has brachiopods in it. But my favorite find was actually this rock right here. This is actually only a piece of it. Exposure's kind of, you see this big orange kind of spot on this rock. This is spessartine garnet. I found this in a creek near my home. That's why I'm in New York. I found a lot of garnets very often. But these are the largest garnets that I found. And just being in this rock was just the outer appearance. You can see there. There's no indication that would have this kind of quartz feldspar matrix, and that this garnet inclusion. And these are huge, and there's so many of these. And I said, this is incredible. I loved posting this video. It was great. But yeah, I found a couple of fossils as well. And that was really fun because you don't always know that you're going to find fossils in a rock. Do you have a favorite mineral video that you made? I do. And that is actually the fossil rock video that I made with the groovy geologist on TikTok. She came up to Binghamton, was giving a talk at my school, and I said, let's film something together. Filmed me breaking open that rock together. It was my most popular video, and I loved getting to collab with her. Really helped refine my geology page, and just a great experience. I like getting to collab with other people. That's the whole point of geology and of social media, to interact with other people. What tools do you need to successfully rock hound? That's a great question. I don't have the tools on me. I should have remembered to bring them. The main tools that I use are, you want to have safety. You want to have glasses, safety glasses. You want to have safety gloves so you don't get cuts, because if you're dealing with this kind of mineral, you're going to get cut a lot. These sharp edges on quartz also, if you're working with obsidian at all, obsidian volcanic glass, very sharp edges. So you want to have gloves. Aside from that, you want to have hammer, or a rock pick or a hammer, chisel, ways that you can break open the rock. I use a sledgehammer, but that's just to get open the bigger rocks. So those are the main essential rocks or tools that you need. By the way, if you want to check out more of my videos, my social media handle is at Rockman Ethan. I'll put that in the chat, just really briefly. And I have all of these videos where I do education. I do my What's Inside the Rock series, and then I just do everything else on social media, on TikTok, Instagram, and YouTube. What are the coolest places that you've looked for rocks and minerals? Great question. So I went to Iceland this past summer. I always say New Zealand sometimes because I did go to New Zealand when I was young, but it wasn't for geology. I got to go on a funny story, actually. I went on a volcano, the one that just erupted in Iceland, but it was dormant at that time. It was dormant for about a year or so. And so I got all of you, and I actually have a piece of basalt here. I'll just get these real quick. I got this kind of ropey texture basalt. And so this is probably one of my favorite rocks that I have. And let me see if I can find it. On this backside, all those little specks, those are all olivine crystals. So they dropped into the magma matrix. And then when this was formed, this rock is almost 2 years old. It's a baby. And then I also have this one. I like this texture on it. It's my favorite rocks. All right. What cool fossils have you found? I also should have brought that over. Great question. Let me just grab that real quick. Trying to find the fossil. Oh, here it is. I think. Yeah. This was actually the rock I used for that video. This is my brachiopod rock. And you have some crinoid fossils as well. A lot of shell fossils where I went to school. But this was the outer appearance of the rock. Very little that you could interpret being a fossil aside from these. I did see these and I thought that there might be a fossil inside, but you never know. But the inside was just amazing. Look how, and this is probably from a what's it called? A storm event or a mass deposition, because they're all in different orientations. So they're deposited all at once, not just falling down at different times. Actually, no, that's not true. If you are being deposited all at once, you're going to be in the same direction. But over time, they're just being deposited differently. So this must be a mass deposition site. If I live in New Jersey, do you know of any cool places to look for rocks? I don't know for any cool New Jersey places. I know there's a lot of mines. But what I always tell people is you want to look for roadside outcrops, and you want to look for creeks and riverbeds, dry creeks or riverbeds, because you can find rocks like this, tumbled rocks, glacial erratics. I think if the glaciers made it down to New Jersey. But you'll find a ton of different rocks, and in the bedrock geology, though, if you look in the outcrops, that's where you can find the specific minerals. So I think I actually made a video covering New Jersey. If not, then you can look in those same resources where you can say, okay, like where in New Jersey am I looking? Northern, southern, and it'll tell you what you can find. Do you have a big rock collection from all the rock hunting you do? Yes. I just went over to grab this fossil, and I literally have boxes of rocks collected through past year, I'd say so. I have rocks scattered throughout here. I have some rocks, I think right there is actually another one of my rocks that I have scattered around my room. There's also more rocks outside. My parents don't want me to bring them into the house. So yeah, I have a lot of rocks. What are the common types of rock minerals that you find where you're from? Like I mentioned before, so I have garnet. If I can grab my piece here. I have this, and I have another piece of garnet somewhere else. Here we go. So the main forms of garnet that I find are almandine garnet, really. I have the spessartine garnet that I also found, but these kind of maroon gemstone garnets. This is in the crystal form. Actually, I can hold it up a little bit closer. And then I have the ones that I find when I break open, and this is garnet right here, this kind of maroon crystal right there. And what looks like to be a, what's it called? Feldspar matrix, but it's a little bit green, which is interesting. I don't want to say fluorite, but whenever I see green, I think fluorite. Excuse my stuffy nose. Is there a place that you really want to go to find interesting rocks and minerals? Yes. I really want to go out west. I haven't gone out west to Rockhound. I just went out west to Denver to go to the GSA conference. That's where I got this sick cup. You can't really see it that much, but it says GSA Connects. Drinking water. I got to present research, but I didn't get to Rockhound. So I want to go out west. I want to go to the mines. I want to find really, really cool rocks. Because a lot of my what's inside the rocks are just metamorphic rocks. So I want to have that opportunity to actually find like geodes and malachite and fluorite and just different things that people haven't seen before. Because people comment on my videos a lot. They say, this guy only finds quartz. And I'm like, yeah, I love quartz, but I understand what you're saying. I want to find more cool minerals. How valuable are the minerals that you find? I would say that the minerals that I find, they're not in large quantities. They're very small. They're very concentrated, and they're not pure. When I find a garnet like this, garnet's probably the most valuable mineral that I can find because it goes into gemstones. It goes into rings, jewelry. But this is in a raw state. I have to extract that mineral. I don't know how thick it is. I'm only breaking apart a little bit of the rock. But it would have to be polished, and then would have to be sold. I'd probably make sense. But there's a different type of value that I use for rocks that I find, and that is the kind of experience and the sense of finding something that no one else has found before. You unearthed that in history, and you were the first person to do it. And it just kind of is really cool to think that rock has not seen daylight. That mineral has not seen daylight for millions of years. And I just unearthed it and I exposed it to the world. And now it's mine. Except if you're finding gold in New York State, then you have to give it to the government. But that's besides the point. If you break open a rock and you like what you find, then that's your rock that is not destroying nature, because rocks are always going to be broken open. That is a natural process. Are minerals that can only be found in New York or New Jersey and nowhere else? Well, like I mentioned before, Herkimer diamonds. That form of quartz is not going to be found anywhere else in the world. So it's not like there's no minerals that you can find anywhere else in the world. But the type and the form, like Gore Mountain garnets, those are going to be very specific to Gore Mountain. Herkimer diamonds. Aside from that, you'll just find mainly quartz, pyrite, garnet, fluorite, sphalerite, different things like fossils too. So you're not gonna not find those things in other states. So geology is actually very expansive, and so you can find a lot of different minerals in every state. But the concentrations, you might not find as much quartz in a different state than you find in New York or New Jersey. And also, New Jersey has a lot of fluorescent minerals. Not sure. Actually, I think there is a type, franklinite. Franklinite, I'm not sure if that's fluorescent or not, but I know that's a certain mineral that is very common in New Jersey. How do stalactites form in caves? And are there any around New Jersey and New York area? So stalagmites are the ones from the ceilings. Stalagmites are the ones on the floor. And you can remember that because I struggle to remember it sometimes, because stalagmites, you can say stalagmites might reach the ceiling one day. Stalactites stay tight to the ceiling. go to Howe Caverns. There are caves. Howe Caverns is one of the best examples of caves in New York, New Jersey. I believe there are also caves that you can go into. I don't know many caves though in the Northeast, but there is one of the things you can do. Go online, search it up for databases for caves. You'll definitely find that. Biggest rock or mineral that you found. Whew, I don't know if I have a big. Actually, no. I'll just get my one over here. I guess I have this piece, and then I have this piece that I just did for what's inside that rock. But I'm gonna end up scratching something. This is one of my fossil pieces. These are all different shells. You can see on the outside, it's very, it's just huge. This is not necessarily a rock that I found. It's a rock that was already broken open. And these are all the shells that were inside. And then you have this rock that I just broke open from an abandoned mine, getting dust everywhere, that has, what is this? Magnesia hornblende in it. And as well as pyrite and, yeah, and magnetite too. Dusty pants now. How do you know which rocks will have interesting minerals and fossils inside, or how do you choose which ones to break open? It is a trial and error sort of thing. I do not get it on the first try. I see a rock that I might like, and I think, oh, well, if it has a little bit of shine on the outside, I think it might be quartz. Or if it has little speckles, I say, oh, that might have a garnet in it. Or if it has an indentation, it might have a fossil in it. But I'm not always right. So I'll do that over and over and over again and say, okay, until I get it right, until I get a good take, then I will use that take for what's inside that rock. What is a glacial erratic? Great question. If you are from one of the northern states like New York, Minnesota, Oregon, Ohio, you will have these massive rocks that you normally find in flat areas that you're just kind of like, how did they get there? And the answer is that the glaciers were a huge and powerful force that just ripped across the landscape, just devastating all of the rocks that were there, but bringing up other rocks sometimes and eroding them and weathering them, tipping them over and carrying them. And then when they receded, they just kind of dropped them off. It was just like a see you soon or see you never, I guess, because the glaciers weren't coming back for them. And they just left them there. So you'll be hiking in the woods sometimes, and you see a gigantic rock out of nowhere. You're like, how did that get there? The glaciers, that's how it got there. Have you ever found a meteorite before? How would I know if I found a meteorite, and what are some places I should look for them? I have not found a meteorite. Very rare thing to find. Best chance you have to find a meteorite is to be where a meteorite strikes. Otherwise, very likely to not find a meteorite. People often find slag, which is just basically the byproduct of smelting. And they think it's a meteorite because it's metallic, it's dense, it's magnetic, it's dark. And they think, well, that's a meteorite. And then we say, no, you didn't find a meteorite just because you think it's a meteorite. You're not likely to find them really anywhere specifically. And like I said, you have to just go to where a meteorite strikes. Otherwise, you can buy one. And if you want to confirm it, there's people who are experts who can do the tests to ensure that it is a meteorite. And finally, what's the oldest rock or mineral you have found? That's a good question. I do not know. I do not specialize in rock ages. I know that the bedrock for the Northeast is very old. So I'm imagining out of the many places that I have rock hounded, it's it's oldest there. So these pieces right here, they might be 100 to 500 million year old minerals. But then I have here, I can go in the opposite and say, what's the youngest mineral I've ever found, the youngest rock I've ever found? And it's this. Like I said, the lava flow. It happened 2 years ago, and this rock was formed then. Just shows you how different bedrocks can represent different ages. And yeah, that is all the questions that I have right now. If anyone else has anything else to say, I'm willing to answer too.
Hey, then thank you so much. I think you got everybody's questions. There were so many, which were really good. And again, like your talk was amazing. So thank you so much for doing this for us. And thank you to our audience for tuning in today. And I just want to make a quick announcement. We are resuming our late night events that are going to be like on the first Wednesdays of like the month. And it's going to be in person. I know previously we were virtual. But this upcoming Wednesday, we have an in-person event at the Geology Museum. It starts at 4 p.m. and will run until 8 p.m. And the theme will be Egypt. So it's going to be an Egyptian night. It's going to be a lot of fun. We'll have crafts and activities. You can definitely stop by between 4 and 8 p.m. And thank you once again, Ethan, and have a wonderful night.
Thank you so much. I really appreciate it.